Okay. My dear Shiny friends and colleagues, it's hard to believe, but we are getting very close to the end of our conference. I hope you're having a great time. I'm super excited to introduce our final keynote speaker, Winston Chang. Winston is a software engineer at Posset and a key member of the Shiny team, having served as its team lead. With over 10 years of experience in the R community, he has contributed to many widely used packages, including Shiny, DevTools, and ggplot, among many others. Recently, Winston has been busy working on Shiny for Python and Shiny Live. He holds a PhD in psychology from Northwestern University and is the author of the R Graphics Cookbook. Today, Winston will be sharing his insights on Shiny's journey into the Python world. His talk will discuss the lessons learned, the opportunities that Shiny for Python opens up, and the exciting new era we are entering together as the Shiny community grows and evolves. Whatever your experience with Shiny is, there's something in this talk for everyone. So let's give a warm welcome on our chat to Winston Chang, and let's learn together how to make the most of Shiny for Python.
Hi, Philip. Thank you very much for that introduction. That was really nice. Okay, so yep, thanks. So today I'm going to be talking about lessons and opportunities with Shiny for Python. So yeah, I should give you a little background here. Shiny for R has been around for over 10 years now. I didn't work on it in the very beginning. It was Joe Cheng that created it in the very beginning, but I joined the team not too long after. So that was, yeah, it's been, over 10 years now. And about a year and a half ago, the Shiny team at, well, it was then RStudio, now it's Posit. We started working on Shiny for Python. And we didn't, when we started working on it, we didn't, we kept it private for a while, but after about a year's work, we were ready to announce to the world, which we did at last year's RStudio Conf. So today I'm going to talk about some of the things that I've learned in that time, a lot of things that I've learned from working on Shiny for Python in particular, and some of the opportunities that I think exist and that I've observed along the way. Okay, so I've got a bunch of different points that I want to cover, and they aren't necessarily in any particular order, but hopefully you'll find them interesting. Okay, so so the first lesson is that 10 years is a long time. It's a long time to develop a code base. So we've been, like I said, we've been working on Shiny for all this time. It's a long time to build tools surrounding Shiny. So it's, Shiny, the Shiny related stuff that Posit makes it's not just Shiny. It's Shiny, there's the web serving layer, HTTP UV, there's BSLib, which Carson just gave a talk on. There's Shiny Test, Shiny Test 2, Shiny Dashboard, all sorts of different things that are built around surrounding Shiny. All right, and we've had a long time to work on all of these different things. It's also a long time for others to build tools that enhance Shiny. So many of the speakers at this conference have built all sorts of really cool packages that help you extend Shiny and make it look better and let you do new things with it. And 10 years is also a long time for a community of users to grow and get to know each other and build connections. So, sometimes I think about Shiny for Python, and in the Python world, for Shiny for Python, we're just getting started, and all this stuff that is great about Shiny for R, all the stuff that has taken time to build, it's not there yet in Python because we only announced it about half a year ago. So and these things don't just happen overnight. They take time and they take effort. So hopefully with time, we'll be able to build these things, and not just us at Posit, but as a community, we'll be able to build all sorts of things together. So that's something that's, I find is interesting to reflect on when I think about how long Shiny's been around. Okay, so the next thing is a little bit more technical. So naming things is hard. This is a lesson that if you've been working on software for any period of time, you've probably learned this. Naming things is hard, especially if these are things that other people are going to be using. The good thing is that it's easier the second time around. So in the early days of Shiny, the names were based on the names of various functions were based on what was common in the R ecosystem at the time. So we end up with the names like these. So we have text input, text output, verbatim text output, plot output, render plot, UI output, and render UI with this different interesting capitalization of UI here as opposed to there. So, over time, we started to wish that we'd use some different names. So for these names, as you can see, we use camel case for most of the names, which is at odds with the snake case used by tidyverse packages. And these days we try to sort of use the same naming convention that tidyverse uses, and you saw that probably in Carson's talk about BSLib. This is how we name our functions now, is using snake case. So it's it is a consistent way of naming functions. But back then, when we created all this stuff, tidyverse didn't exist. There was a bunch of packages that eventually became the start of the tidyverse, but the tidyverse itself did not exist. The other thing is that we wish that we had names that were more discoverable and auto-completable. So if you're writing your Shiny application and you want to know what kind of outputs there are, you can't just type output and then hit tab and then it'll have it pop up a list. You have to know you want a text output, or you have to know that you want a verbatim text output. You have to start typing the TEXT and then hit tab. Then you'll see that there's text output, but that still won't show you that there's this other, this verbatim text output. So now the render functions are a little different. They all start with render, so there is some autocomplete more discoverability there with autocomplete. But so anyway, when we worked on Shiny for Python, we actually talked quite a bit about what we should name things, and so this is what we came up with. So on the left we have the names of these various R components, and on the right we have the Python names. So we have slider input, text input, data input, action button. That one's a little bit different, doesn't say input on it. And in Python, all of these, I've prefaced them all with UI dot because they're in the UI submodule of Shiny. So typically you'd write them out like this, but you don't have to in Python. But you would say like UI dot input, and then if you hit tab, you'll get a list of all these different types of inputs, including the action button. So I think that's a big benefit for people that are learning, or even if you're experienced and you have been away from writing Shiny stuff for a while. When you come back to it, this will help you get things done faster. And the same is true for the outputs, right? So it's UI dot output, and then you hit tab, and then there's all these different options that you'd have come up, and they're named more consistently than the ones over here, like with the capitalization. The UI is just, it's always lowercase. And finally, there's these render functions. So in R, it's like render plot with capital P, render text, render table, render UI, where both of those letters are capitalized. And in Python, these are all part of the render submodule. So we have render.plot, render.text, render.table. So even if you don't remember that, there's a period here as opposed to an underscore over there, if you hit tab, in your editor, you'll get some assistance to help figure that out. So that's one thing that is really nice with the benefit of hindsight, and to be able to go and do this when we're working on Shiny for Python. So we had a good reason to use these new names and to try out a new naming convention, and then this could be, hypothetically, we could use, we could create aliases for these that look like this in R, so that these things are more discoverable in R as well. And there's a couple other things that I want to touch on in terms of naming. So for reactive components, so like the actual reactivity stuff. So I've long wished that we had names that are easier to talk about, and easier to understand, and more in line with present day standards. So in particular, the two functions that I'm talking about are reactive and observe. So with reactive, this one has always been a little bit difficult to talk about, because you can say this is in our documentation, we call it a reactive expression. But the function name is just reactive. So sometimes we say, oh, this is a reactive, like as a noun. But we also say that things are reactive, like an adjective, like reactive values are reactive. This reactive expression is reactive, and observers are also reactive, like they're all part of this reactive computation model. So that is a little bit confusing to write about. And the other thing is that a reactive expression isn't exactly an expression. It's typically, when you're talking about computer stuff, when you say you have an expression, you have to explicitly evaluate it. But this kind of reactive expression is actually more like a function. You invoke it to get the value. So that name has always been a little bit difficult to write about and talk about. And also observe is also a little confusing. I think people don't really know what observe means. And you can explain to people that it involves, for observe, you give it an expression, and that expression, we're not interested in the return value. We're only interested in the side effect of that code. So, but still, it's easy to forget that. So in Python, we've used some different names. We used reactive calc to represent the same thing as a reactive expression in R, or this reactive function name. And for observe, we're calling it a reactive effect. So this lets us use the name reactive as an adjective. Like this thing is reactive, this calc is reactive, an effect is reactive, a reactive value is also reactive, and then there's not that ambiguity of like, are we talking about this adjective reactive or a noun reactive? So this is a reactive this is short for reactive calculation. This returns a value, and this is a reactive effect, which you give it a function that you want to execute for its side effects. So, and that's in line with if you've ever used the web framework, the JavaScript web framework called React. There's something called useEffect, and you give that a function that executes for its side effects. And again, you still have to understand like what is a side effect in a function, but at least it's right there in the name. Like this is, it is informative what that's for. Okay, so the next thing that I learned working on Shiny for Python is that learning Python is not that hard if you have a reason to learn it. So now this actually shouldn't, this shouldn't really be surprising for people, because Python has a reputation as being one of the easiest programming languages to learn. So it's not that hard, but you might be wondering, well, will I be a total beginner again, like programming language beginner if I start learning Python, or will my R knowledge transfer over to Python? And this actually, this is a more interesting question than it might seem on the surface, because R is kind of an unusual language. So I'll just point out a few of the things that sort of stand out about R that's weird. So in R, you have one-based indexing. So if you want to get the first element of a vector or the first row of a data frame, you start counting at 1, and in Python you start at 0. And so, and most programming languages are like Python. R, there's no scalar values. There's just length 1 vectors. And in Python, there's a distinction between scalar and vector objects. So if you got a single value versus like a whole, like a vector of values. Next, so R is a Lisp-like functional language. And Python is an imperative object-oriented language. Now, this thing about R being a Lisp-like language, if you look deep into the source code of R, you'll see that it's actually implemented just like Lisp. It's very different from other programming languages or other common programming languages. And I'll talk about this a little bit more. Okay, and also our data frames and statistical tools, they're deeply embedded into the language. And with Python, all that stuff, that's all, that all comes from third-party modules. Now, I think if you're an R user, some of these things are actually not that hard to deal with. Like 1-base indexing versus 0-base indexing, you can do it. It's not that hard to switch from one to the other. These scalar values versus no scalars versus having explicit scalar and vector objects, that's also not too hard to deal with, because with R, the way the syntax is in R, it lets you treat length 1 vectors, lets you write them sort of like scalars in other languages. So this transition, actually, it's not that much of a transition in practice. Now for the next one, so R being a functional language and Python being this imperative object-oriented language, they're actually quite different at the core, but at the user level, the two languages aren't so different. Both of them are somewhat functional languages, and also both sort of object-oriented languages. So what I mean by being functional languages is that Python supports first-class functions. First-class function is a function is an object that you can pass to another function, and that then it can invoke that function later. Or you can compose those functions. So R does that, and Python can do that as well. Although the syntax for it is can be a little bit clunkier in Python. R also is flexible enough that you can create an object system that allows for object-oriented programming similar to Python. All right, so you can do this in R. So they're both flexible enough. Both of these languages are flexible enough that there's a lot of overlap in the knowledge that you have. But there actually is one important difference. So in R, most data structures are immutable, and in Python, most data structures are mutable, meaning they can be changed. If you have a data structure, it can be changed from anywhere else in your program. Well, if that part of the program has a reference to the object. So I'm just going to illustrate this with some code from a Shiny app. This is the server code for a Shiny app. So let's say you've got a data frame. It's just got 2 columns of numbers, and then you have a render table. So let's say you want to render this table so that the Y column prints with 2 digits after the decimal point. So they look like this, 0.10. All right, so what I'm going to do is I use the sprintf function, I give it my string format, and then the column, and then I store that back in the data frame. And then I return the data frame. But this time it has a column of strings. And then the table that gets printed out will have numbers like that. And finally, I'll do a render plot where I just plot the X and Y values as a scatter plot. And what you'll see for that scatter plot, it'll look like this. This shouldn't be a surprise. So the X values are those X values, and the Y values are the Y values, 0.1, 0.25, and 1.6. All right. Now we can look at the same code in Python, and if you haven't seen the Shiny for Python code, well, here's your chance. This is it's not so different. So if you create a data frame using pandas, I say PD data frame, and I give it my values here. And then I do a render table, and this is in Python. This is how you format your numbers into strings with 2 values after the decimal point. And I save that back in my the y column of df. All right, and then I return that data frame. Excuse me. And then I'll do the render plot, and I can use the ggplot function here because this application uses plot9, which is it's a implementation of ggplot for Python, which works remarkably well. So if you've used Python and you haven't used plot9, you should definitely check it out. Anyway, if we do this, then we get a plot that looks a little different. All right, this looks like more like a straight line. So let's put these 2 plots side by side here. So in R, you have this sort of, this thing that goes with an upward trend here. And in Python, it almost looks like a straight line. And if you look at these y values, it's a little weird. It's just 0.1, 0.25, and 1.6, and these are evenly spaced. So why did this happen? This is something that is points to a really deep difference between R and Python. So in the R version of the code, when we created this column of strings, and then we saved it back into the data frame. When you do this assignment here, R actually makes a local copy of this data frame df when you write to it. So it does it in a way that's usually it does it in a way that's efficient, so it doesn't have to copy everything. But it makes a local copy of df within this scope here, those curly braces, and then it returns it. And that does not affect this df. So this df refers to the original data frame. And so you might not have ever even thought about this before, but those 2 things are this df and this df are can't affect one another. And so you get that scatter plot like the one that that you see on the screen there. Now in Python is actually more like the way that Python works is like more programming languages. So R is actually the weird one here, even though it behaves in a way that is convenient. So in Python, when you do this assignment here, you say df bracket y equals this thing here. This actually alters the data frame in place. So this df refers to some object, it's a data frame, and then bracket y, and then I'm assigning to that. So I'm altering that data frame in place. It doesn't make a local copy. So then when I come and run ggplot, this df is actually the altered data frame where the y column has strings, and that's why it looks like this. These are actually categorical variables. All right, so that they look like numbers, but they're actually just strings here. All right, now you can fix it in Python. Fix the code by when you're working with df up here and you're modifying it, you say df.copy, and then I'm saving that as df2, and then I do all this stuff. I assign it into df2 and then return that. So that doesn't alter this df that I'm plotting here. But you have to be aware in Python of like, oh, is this thing a reference to an object that somebody else has? If I alter it, do I have to, can I make a shallow copy, or do I have to make a deep copy? These are issues that you have to think about with Python. So in this respect, like R is actually a lot better to work with than Python is. But people do this all the time, and people write Python code. They manage to write Python code. So, but you do have to be aware of this thing. All right. Sorry. Yes, I forgot to put the move the slides ahead. All right. Now the other big difference is that data frames and statistical tools in Python are in third-party modules. So what I've found is that the basic manipulation of tabular data in Python with pandas is kind of clunky and unintuitive. Now, this is obviously just an opinion. This is my opinion. But I've talked to other people, and people who aren't really R users seem to agree that it is working with data in Python is, it's kind of awkward. So it's my opinion, but I'm also right. So there you go. Now one good thing about it, those these things being in third-party modules for Python is that there are, other competing data frame libraries out there. And so there's other, it's possible for something else to come that is easier to work with or faster, or whatever advantages you can think of. But at this time, it is like the go-to library for manipulating tabular data in Python is pandas. So yeah, that's where it's at now. Maybe it'll change in the future. Okay, let's see, another lesson that I learned. So is that Shiny's technology still stands up well. So coming into the Python space with a web framework. So there are other things out there that already exist. So for example, there's Dash and Streamlit. These are two popular web frameworks that have like roughly the same level of abstraction and would be used by similar people that are doing data science. Shiny's been around, like I said, it's been around for 10 years, but I think the technology still holds up really well. So, if you compare it to Dash, now these are again, I'm going to just preface this by saying that these are my opinions. This is subjective. So take it with a grain of salt. But Dash, to me, it seems like kind of hard to use for a non-web developer. If you don't already know a lot about how to build how web pages are built, Dash, well, it's going to force you to learn those things if you want to make something nice. And if you look at the core of Dash, like the computational model, it uses an explicit callback model instead of reactivity, which means that you have to be a lot more explicit about how the relationships between various components are set up, whereas Shiny can figure those things out automatically for you. And the specific way that they've done it with Dash can result in a lot of data being sent back and forth between the client and the server, because they try not to keep any state on the server. Which, there's benefits to that, but there's also drawbacks. All right, so now if we compare it to Streamlit, Streamlit is an interesting thing. It's gotten very, very popular, and there's a reason for that. It's super easy to get started making a Streamlit app. And that's because you can start with a script doing your data analysis, and then you can turn that into a Streamlit application by adding some lines of code, right? You don't have to like rewrite the whole thing. But the issue with that is that you quickly hit a ceiling of what you can do with Streamlit. And this is a trade-off that they chose to make, and it obviously works for some people. It works for a lot of people, but it can be quite limiting. So what's really limiting about it is the execution model. So basically, every time something changes, every time an input changes, like if you move a slider, or you type in some text, it'll re-execute the entire script each time something changes. And they have stuff, they have a lot of features that can make that more efficient, so that it's, you don't have to do like massive data processing every time like somebody moves a slider, if you set up your caching correctly. But there is a limit of what you can do with caching, and there's just a limit to what you can do in general with a model where it just re-executes the whole thing every time. But it is easy to understand. So what's happening. So there is that. But again, I think Shiny's technology, the reactivity, it holds up really well compared to what else is out there. And there's some other newcomers out there which which I'm not talking about here because I don't know enough about them yet. All right. Let's see what else. So the next lesson is that looks matter. What do I mean by that? Well, we know from talking to users that it's really important to be able to easily create nicer looking apps. And So when Shiny came out, it was really impressive what, the way that things looked. It was really impressive what you could do with a small amount of code. But now there's other things out there that can do, there's other frameworks that can do nice looking apps pretty easily. And so, like I said, like if you saw Carson's talk prior to this one, we're working on building the foundation to make it really easy to create nicer looking apps. But that's like the foundational stuff right there. Not like maybe the really smarter surface level. Like if you want to make it really easy to create nice looking apps, we're not quite there yet. But it's also like why Shiny Dashboard is really popular despite its age. Shiny Dashboard has been around for a number of years now, and it looks okay. Maybe looks a little bit dated, in my opinion, but it's still quite popular because it's really easy. It's just like, it's really easy to just create something that looks professional, or at least professional enough, and you don't have to think about it too much. And of course, there's many third-party packages out there, like Shiny Semantic from Epsilon, VS4 Dash, from our interface. But yeah, so looks matter, and this reminds me of something. I think Hadley Wickham said this once, maybe not quite in these exact words, but with ggplot2, people came for the beautiful plots, and they stayed for the beautiful conceptual model. So I think that's a really useful way of thinking about things, and hopefully with Shiny for Python, we'll be able to do something similar. So, and again, it is something that we're working on for Python. Okay, next lesson. Balancing progress and backward compatibility is hard. So for Shiny, we originally shipped it with like batteries included, in quotes there, which makes things easier for users to get started. So we had everything that you needed in one package. All right. We had sliders, we had Bootstrap for the web page layout, and so on. So in the beginning, though, we actually had a different slider library than we use today. We used an older version of Bootstrap. We used an older version of jQuery. And changing these things is hard. The more users you have, the harder it is to change them. So with the slider library, changing that was a challenge, although we did it a long time ago. Like, what if your slider generates steps at different sizes? Then if your new slider generates steps at different sizes from your old slider, then people's apps might behave a little bit different. And we bit the bullet and we just did it when we just changed it at some point. But the more users you have, the harder it is to change that. And similarly with Bootstrap version 2, at some point we switched it to Bootstrap version 3. But that involved changes to markup, that involved changes to CSS classes. And we provided a shim for people to do that. But now with BSLib, and the Bootstrap project in general is on version 5, and that's what BSLib is using. So being able to move people onto that, it takes work. You can't just like upgrade it and then everything's going to keep working. jQuery version 1, we moved to jQuery version 3, and then there are some subtle page loading issues that could happen in some cases because some callbacks would fire at different times with the new version of jQuery. So yeah, so changing these things can be hard. But the good news is that Shiny for Python sort of provides a laboratory and gives us a place and a reason to try new things and port some good ideas back to R. So there's motivation to try to change these things, like to change function names. And if things work well, then we can take some of those good ideas and bring them back to Shiny for R. All right, next. The Python world is big. It is very big. So I read a survey that Stack Overflow gave out in 2022, and in their survey, they found that 48% of users use Python and 4.7 use R. So that's 10 times as many people that use Python. And that's almost half of the people that use Stack Overflow. So that's an enormous percentage of programmers. Now, it is true that that in Python, like Python users cover many different domains. So only some of those users do data science, and in R, almost all the users do data science. So that means that not all Python users are necessarily people that would be interested in creating interactive data web applications, but enough of them are that it's a really large population. So in the R community, Shiny has a really large mind share. In the Python community, it doesn't, and that's something we have to earn that. And like I said earlier, at this stage, I think we have the best core technology. And we're working on better documentation and app aesthetics to earn that mindshare in the Python community. So if you're thinking about learning Shiny for Python, remember that it is a really big world out there, and there's a lot of Python shops out there that might be interested in the things that you can create. So this could open, learning Shiny and building cool web apps could open up a lot of opportunities there. But also remember that for now there's a steeper hill to climb to convince people to go with Shiny. So and hopefully that will change over time. But Shiny is it's the new thing in the Python community, as opposed to like something that's been around and more established. All right, next lesson. The R community is great. So R, as I'm sure everyone here knows, has a very inclusive and welcoming community. And people in the R community really put a lot of work into this. It doesn't just sort of happen by itself. And in contrast, Python, well, it has pockets that can feel like that, but that feeling is not as widespread. So it's something that I always appreciate about the R community, and it's something that it's a feeling that we try to foster where we can. But again, Python is a very large community. All right, another lesson that we've learned, which is that WebAssembly is very cool. So WebAssembly is what makes Shiny Live possible. And so if you don't know what Shiny Live is, I'll give you the really brief overview. So it is Shiny, currently Shiny for Python, without a server running Python. So when you deploy a Shiny application, you need a server that runs Python or R, and then that serves the application, and the user loads their web browser and they connect to that server. With Shiny Live, Python runs inside of the browser itself because it's compiled to WebAssembly, and browsers can run programs that are compiled to WebAssembly. So you don't need a separate server running R or Python. And this allows for deployment on static web hosts, which can scale to extreme amounts of traffic for extremely low cost. So that's great if you have an application that, for certain classes of applications, if you need to handle a lot of traffic, and they don't have some certain needs, which I'll talk about in just a minute, Shiny Live is really great for that. So it's not appropriate for all use cases. Like you can't keep any secrets. If somebody can run your application on their computer, you don't want to put any like secret authorization tokens or anything like that in there, because they'll have access to them. You can't make secure database connections, and it's not necessarily good for large data sets, because you might not want to transfer large amounts of data to each user's browser. Okay, but so even though it has those limits, it's still the really good thing about it is that you can use the same knowledge of Shiny to create Shiny Live applications or traditional Shiny applications, whichever is appropriate. It's the same. You know, you're just writing a Shiny application. There's just a few different things that you can do between regular Shiny and Shiny Live applications. So you can deploy it whichever way is appropriate. And this gives you much more range in the space of like the web applications that you can create. So just a little history about it. It started off as Shiny Live started off as an experiment. You know, we took some time in when we were developing Shiny for Python to it was a few months into it, we took some time to sort of explore like, hey, what's happening in the Python data science world, and we came across Pyodide, which is this build of Python for WebAssembly, and I was like, okay, you know what? It'd be really cool if we could just run this in the browser. If we could run Shiny entirely in the browser without a server, and you know, it worked out better than we expected. So that was really exciting to see it come together, and we learned something from that experiment, which is that WebAssembly is awesome, and it's, you know, it's great for educational material. Learners don't have to switch away to a different app or web page to run code. If you've looked at the Shiny for Python website, there's on each page there's examples that you can run, and they're just running right in the user's web browser. So people don't have to switch context to somewhere else. They don't have to, you know, you don't have to spin up a server somewhere, install an application. You just can run it right in the web page. And also, from the perspective of somebody who creates this stuff, the content, you don't have to worry about hosting, because you can put in a static web host, which is very cheap, or scaling, or security, like all that stuff. Like, you know, that's not an issue. Security, we used to have people, I could probably still do, running crypto miners in like our RStudio cloud instances. And that's just not an issue. If somebody wants to run a crypto miner in Shiny Live, that's fine. They're running on their own computer. So good for them. And this brings me to WebR. So this is R compiled to WebAssembly running in the browser. And this was created by George Stagg. And you know, as an organization, what we learned from Shiny Live helped convince us that it would be worthwhile to hire George to work on WebR full time. So when he started it, he wasn't working at Posit, but what we learned from working on Shiny Live, it's like, oh, this is the real deal. This was worth, you know, getting George to work on this full time. So and you may have heard WebR had its first release 0.1.0 last week. So if you should definitely go check it out if you haven't already. It's really cool to see you can run R code right in the web browser. And of course, the reason I'm talking about this is, yes, we are working on Shiny Live for R. I can't give a firm date for this, but it is something that we're working on. Okay, so for the R users out there that know Shiny, Shiny is a great reason to learn Python. So here's what I mean by this. So there's many groups out there that use Python and not R. And knowing Shiny well is a good way to have access to both Python and R shops. So if you know Shiny for R, I think you can quickly learn Shiny for Python, even if you don't know that much Python to begin with. And then if you start working with a group that does Python, you can be an expert in something right from the beginning. So you can be useful right from the beginning with a Python group. Whereas, you know, if you just know R, and then you want to start working with some Python people, you might otherwise just have to start from the beginning and be like a total novice. But if you learn Shiny for Python first, you can do something that's really useful and unique right away. All right, and for Python users, Shiny gives you options. So if you're a Python user and you learn Shiny for Python, you can create traditional web applications that run on a server. You can create Shiny Live web applications, and you can use your knowledge to write Shiny for R applications. This, again, if you're just it's similar to what I was saying about R users learning Python. If you're a Python user and you want to learn R, you can transfer that Shiny knowledge and be over to R and be useful right away, and start working with R users. And that's it. That's what I have to say. Thank you very much. Thank you for listening to what I have to say.